In the last lecture, I explained what propositional connectives are. I described a particular category of propositional connectives that we called truth functional connectives, and I gave you an example of one truth functional connective, and. Now, the word and in English isn't always used to mean a truth functional connective, but sometimes it is. And one thing that I'd like to point out right now is that there are other words in English that can be used to indicate the very same truth functional connective that the word and is used to indicate. For instance, think about the English words also, moreover, furthermore, and but. Now, you might think the word and the word but mean two very different things. If I say Walter is poor and happy, that seems to mean something very different from Walter is poor but happy. In particular, when I say Walter is poor but happy, I'm suggesting that there's a contrast between his poverty and his happiness. But when I say Walter is poor and happy, I'm not suggesting any such contrast. Still, whatever contrast there might be between his poverty and his happiness doesn't affect the truth table for the truth functional connective but. Let's consider when it would be true to say Walter is poor but happy. To show you what I mean about the words but and, let's go back to the truth table for the truth functional connective and. So remember, if you have two propositions, P1 and P2, and you use the truth functional connective and to put them together to make another proposition, the proposition P1 and P2, and now you want to know when is that new proposition, the proposition P1 and P2, when is that going to be true? Well, the answer is it's going to be true only when P1 is true and P2 is true. In any other scenario, the proposition P1 and P2 is going to be false. Let's take an example so I can illustrate. Let's suppose for P1 we use the proposition Walter is poor, and for P2 we use the proposition Walter is happy. Then we use the truth functional connective and to put those two propositions together into a new proposition. And the new proposition is going to be Walter is poor and happy. Okay, now when is it going to be true that Walter is poor and happy? Well, if it's true that Walter is poor, and it's also true that Walter is happy, then it's going to be true that Walter is poor and happy. But if it's false that Walter is poor, then it's not going to be true that Walter is poor and happy. And if it's false that Walter is happy, then it's also not going to be true that Walter is poor and happy. So the proposition Walter is poor and happy is going to be true only when Walter is poor is true and Walter is happy is true. In any other possible scenario, the proposition Walter is poor and happy will end up being false. So let's compare that to the proposition that we get by combining Walter is poor and Walter is happy with the connective but. Walter is poor but happy. Now, when is it going to be true to say Walter is poor but happy? Well, it's not going to be true to say Walter is poor but happy in any situation where it's false that Walter is poor, right? If it's false that Walter is poor, then it's also going to be false that Walter is poor but happy. It's also not going to be true to say Walter is poor but happy in any situation where it's false that Walter is happy. If it's false that Walter is happy, then it's going to be false that Walter is poor but happy. So when is it going to be true that Walter is poor but happy? The only possible situation where it could be true is a situation where it's true that Walter is poor, and it's also true that Walter is happy. Now, you might think, wait a second, when I say Walter is poor but happy, I'm saying more than just that Walter is poor and that Walter is happy. I'm also suggesting a contrast between his poverty and his happiness. And maybe that suggestion is misleading. Maybe poor people are often happy. But notice, what you say can be misleading even if it's true. For example, suppose someone comes up to me with a car that's sputtering. They might say, "Do you know where there's a gas station around here? I need to fill up this car with gas." And I might say, "There's a gas station just around the corner." Now, what I say might be true. There might really be a gas station just around the corner, even if I know that that gas station has been closed for 3 years and has no gas. So what I say is misleading because I've led them to believe, falsely, that they can get gas if they can just get their car around the corner. But even though what I've said is misleading, it's still true because there is a gas station around the corner, only a closed one. So what you say can be true but misleading. And I suggest that when you say Walter is poor but happy, that can be true even if it's misleading to suggest that poverty and happiness are somehow at odds with each other. I've just said that the word but in English can be used to indicate the same truth functional connective that the word and is sometimes used to indicate. And there are other words in English that can be used to indicate that same truth functional connective. Also, furthermore, moreover, and sometimes we even use the word to, T-O-O. But now I want to introduce a term that's going to describe that truth functional connective no matter what word in ordinary language we use to indicate that connective. The term is conjunction. And the term conjunction, as I'm using it here, and as philosophers use it, is not the same term that grammarians use when they talk about conjunctive terms like but, or, and, therefore. Here's something that could help you understand what conjunctions in the grammarian sense are like. All of those terms are conjunctions in the grammarian sense, but they're not conjunctions in the philosopher's sense. A conjunction in the philosopher's sense is just the truth functional connective that has this particular truth table. You can use the conjunction to create a new proposition out of joining two other propositions, and that new proposition that you create using conjunction is going to be true only when the other two propositions are true. In any other case, the new proposition is going to be false. That's what a conjunction is. And we can use the symbol ampersand, like that, in order to signify conjunction. Now that we know the truth table for conjunction, let's consider how we can use that truth table to figure out when an argument that uses conjunction is valid. Consider the argument, Walter is poor but happy, therefore Walter is happy. Is that argument valid or invalid? Well, pretty obviously that argument is valid. There's no possible way for the premise to be true while the conclusion is false. But can you see why the argument is valid using the truth table for conjunction? You should be able to. In a situation in which the premise is true, Walter is poor but happy, there are going to have to be two other propositions that are true. Namely, Walter is poor and Walter is happy. So, if it's true that Walter is poor but happy, then it's going to have to be true that Walter is happy. And that's why the argument is valid. That's why there's no possible way for the premise to be true while the conclusion is false. Let's consider some other arguments that involve conjunction. Consider the argument, Walter is poor, Walter is happy, therefore, Walter is poor and happy. Is that argument valid? Clearly it is. And again, you can use the truth table for conjunction to see why it's valid. In a situation where the first premise, Walter is poor, is true, and in which the second premise, Walter is happy, is true, in that situation, the conclusion Walter is poor and happy is going to have to be true. So there's no possible way for the premises of that argument to both be true while the conclusion is false. And so that argument is also valid. Now notice, just as we can combine two propositions with each other using conjunction, we can then also combine the resulting proposition with another proposition using conjunction. So, consider the proposition, Walter is poor, but happy and popular. That proposition uses two conjunctions to combine three other propositions into a single conjunctive proposition. To understand how that works, let's look at the truth table for that. So when is it going to be true that Walter is poor, but happy and popular? When is that going to be true? Well, if it's false that Walter is poor, then it's definitely not going to be true that Walter is poor but happy and popular. So in all of these situations right down here, Walter is poor but happy and popular is going to be false. If it's false that Walter is happy, then it's definitely not going to be true that Walter is poor but happy and popular, because he's not going to be happy. So, in these situations right here, where it's false that Walter is happy, it's also going to be false that Walter is poor but happy and popular. And if it's false that Walter is popular, then, of course, it's also going to be false that Walter is poor but happy and popular. So, in this situation right here, it'll be false that Walter is poor but happy and popular. So, is it ever going to be true that Walter is poor but happy and popular? Yes. It'll be true just when it's true that Walter is poor, it's true that Walter is happy, and it's true that Walter is popular. That's the only situation when it's going to be true that Walter is poor but happy and popular. In general, this is the kind of truth table that we get when we combine three propositions using conjunction. So now consider how we can use the truth table for conjunctions of three propositions to figure out whether certain deductive arguments are valid or not. So consider the following deductive argument. From the premises, Paris is the capital of France, Jakarta is the capital of Indonesia, and Washington, D.C. is the capital of the United States, let's conclude Paris is the capital of France, and Jakarta is the capital of Indonesia, and Washington, D.C. is the capital of the United States. Valid or not? Well, clearly that argument is valid, and the truth table shows us why. The conclusion, Paris is the capital of France, and Jakarta is the capital of Indonesia, and Washington, D.C. is the capital of the United States, is true just when it's true that Paris is the capital of France, and it's also true that Jakarta is the capital of Indonesia, and it's also true that Washington, D.C. is the capital of the United States. So whenever the premises are true, the conclusion is also true, and that's why that argument is valid. The truth table explains why the argument is valid. Now consider a different argument. From the premise, Mick Jagger is a singer, a man, and a septuagenarian, we can draw the conclusion Mick Jagger is a septuagenarian. Now, is that argument valid? Yes, it is. And the truth table for conjunction explains why it's valid. Think about the situation in which it's true that Mick Jagger is a man, a singer, and a septuagenarian. The only situation in which that's true is the situation in which it's true that Mick Jagger is a man, it's true that Mick Jagger is a singer, and it's true that Mick Jagger is a septuagenarian. But that means that if the premise is true, then the conclusion has got to be true. The premise is only true in a situation in which the conclusion is true. And so that argument has got to be valid. And the truth table for conjunction explains why. I've said that conjunction can be used to connect two other propositions into a new proposition, and conjunction can also be used to connect three other propositions into a new proposition. But there's no limit to the number of propositions that can be connected using the truth-functional connective conjunction. Or, as we could say, there's no limit to the number of propositions that can be conjoined. You can conjoin 4 propositions, 5 propositions, or however many you like. And notice that there's a pattern to the truth tables for all of these conjunctions. In every case, the conjoined proposition is going to be true only when all of the propositions that are conjoined in it are true. Now, I'd like you to take several minutes and look at the following truth tables and identify which of these truth tables are truth tables for conjunction and which of them are not. Well, that's it for our discussion of conjunction and reasoning with conjunctions. In the next lecture, we'll introduce the topic of disjunction and reasoning with disjunctions. See you next lecture.